Hello everyone, welcome to Mathematics Step by Step. I am Ying. So today we'll be learning on how to interpret the distance time graph and then describe the motion based on the graph, okay? So let us look at diagram 1, okay? So this is a distance time graph because we can see the y-axis is distance, x-axis is time, okay? From time 0 to t1, it is a positive gradient here, okay? So what is represented by OA? Positive gradient. Gradient of OA represents the speed of motion, okay? This is what we have learned in the previous video. The gradient of a distance time graph represents the speed, okay? So it is with a uniform speed and the distance traveled is s1 meters, okay? In a period of t1 seconds, okay? All this information we can interpret from the graph given, okay? Then AB here, we can see gradient is equals to 0 here. It means that the object is in stationary, okay? It's not moving. So the object is stationary for the period t2 minus t1 seconds, okay? Then from t2 to t, again positive gradient. So the motion continues to C, okay? So what we can say from the origin to C, in conclusion, the object travels for S meters in T seconds, okay? Then let's look at diagram 2. We can see that it is also a distance time graph because y-axis here is distance, x-axis here is time, okay? So we can see OP here. It is positive gradient, okay? So from time 0 seconds to t1 seconds, the object moves for s meters in a period of t1 seconds, okay? Then PQ here again 0 gradient, okay? So the object is in stationary, okay? No change in distance. Stationary for the period t1 minus t2 seconds, okay? Then QR here is negative gradient, okay? So negative speed shows the object moves back to original place, okay? Let's say the original place when t equals to 0 here is at home, okay? Then S here is gym. So negative gradient from point Q to point R means going back home from gym, okay? Or the negative speed shows the object is moving in the opposite direction, okay? Later on, we'll look at more examples so that you can understand better. Then OR. OR meaning that from the starting point to the end point, what conclusion can we make? The motion of 2s meters to and fro in a period of t seconds, okay? So like what I've shared with you just now as an example, initially, let's say Ali is at home, okay? Then he went to gym. Then from t1 to t2 seconds, okay? And then he go back to his house, okay? So from his house to gym room is s meters. So in total, he already traveled for 2s meters, okay? So now let's go through this example 4. The distance time graph. Y-axis is distance, x-axis is time in hours, okay? Shows the motion of a car and a tour bus. So the car is represented by the pink color line and the tour bus is represented by the green color line. Graph OA represents the motion of the car from Puchong to Malacca. So we know that graph BC represents the motion of the tour bus from Malacca to Puchong, okay? Opposite direction. Determine the difference in speed in kilometer per hour of the two vehicles. So we know that speed is equals to distance over time, okay? What we are going to find now is the speed of car and then we'll find the speed of the tour bus and then we'll minus, okay? So the speed of car, we'll get the gradient for the pink color line first, okay? So we have 2 points. First is the origin, 0, 0. Another point is here, which is 150, okay? So we will find the gradient now. 150 minus 0 km divide by 2 minus 0 hours. So we get 75 km per hour. This is the speed of the car. Then for the tour bus, okay, again, we can get two coordinates from the graph. First is this point, which is 0, 150. Then another point is here, which is 30, okay? So the gradient 0 minus 150 kilometer over 3 minus 0 hours, okay? So we get negative 50 kilometer per hour, okay? But we can ignore the negative sign because it means that the car is moving in opposite direction. So this is the speed, okay? 50 km per hour. So the difference in speed will be 25 km per hour, okay? Then now let's go through example 5 together. The distance time graph shows the motion of a car for a period of 4.5 hours, okay? Determine the duration when the car is stationary. So now we can see that this part of the graph is with 0 gradient, so meaning the car is at rest from the 2nd hour to the 3rd hour, okay? So stationary period will be 1 hour, okay? Then A part 2, the speed in kilometer per hour of the car in the 1st hour. So meaning that we want to find the gradient of this part of the graph, okay? So the gradient of this part of the graph is the same as the gradient of this line, okay? From 0 hour to 2 hour, okay? So again, we can get two coordinates. First is the origin, second point is here, which is 150, okay? So 150 minus 0 divide by 2 minus 0 hours. So 75 km per hour, okay? Then part B, describe the motion of the car for the last 90 minutes. So last 90 minutes will be here, okay? So first of all, we'll find the speed. So in order to find the speed, we'll need to find the gradient of the graph. So again, we can get 2 points, this point and this point, which is 4.5, 270. Another point is 3, 150, okay? So we find the gradient 270 minus 150 divide by 4.5 minus 3 hours, which is 80 km per hour, okay? So what we can describe about the motion is the car travels for 120 km from the 3rd hour to the 4.5 hour, okay? It travels from 150 km to 270 km, okay? So in total, the car travels for 120 km with a speed of 80 km per hour in the last 90 minutes, okay? So whenever we were asked to describe the motion, there are 3 things that we need to involve, okay? First is the distance traveled, second is the speed, and third is the time taken, okay? So let's go through this example 6 together. Sahana cycles to the post office to send Hari Raya Aidilfitri greeting cards to her close friends. The distance time graph shows Sahana's journey from her house to the post office and back, okay? So determine the total distance in km for Sahana's whole journey, okay? So we can see that from Sahana's house, the origin to post office here, okay, is 2 km. And then from post office back to her house, again 2 km. So in total, she traveled 4 km. Then part 2, the value of t if Sahana cycles with a speed of 8 km per hour to the post office. So we are given the speed now. So speed equals to distance over time. So the speed now is 8 km per hour. Distance is 2 km. Time taken we don't know, okay? We let it be t. So we get t equals to 2 km divided by 8 km per hour. So which is 0.25 hour, okay? Which is 15 minutes. So we know here t is equals to 0935, okay, in 24-hour system. So we have found the answer. Then part B, describe Sahana's journey from the post office back to her house. So meaning is this part of the graph, okay? So we'll find the speed, okay? The speed is the rate of change in distance. So the distance traveled is 2 kilometers, okay, from post office back to her house. Then the time taken is 20 minutes, okay? So 20 minutes we convert to hour is 1/3, okay? So we can write 2 km over 1/3 hour, okay, is equals to negative 6 km per hour. Again, negative is representing opposite direction in this case, okay, for a distance time graph. So the speed is 6 km per hour, okay. Then motion with different speeds, okay. Let's refer to this graph. We can see the gradient for this part and this part of the graph is different, okay. This part of the graph is steeper. So now we learn about average speed. Average speed will be the total distance traveled divided by total time, okay. So now let's go through example 7 together. Zabeda wants to visit her friend in Muar. The distance time graph shows her journey by car from Segamat to Muar, passing through Tangkak. Calculate the average speed in km per hour of Zabeda's journey from Segamat to Muar. So average speed is total distance divided by total time. So total distance is 80 km. Total time is 1.5 hour, okay. So we have found the average speed. Then part B, if the rate of change in distance of the car from Segamat to Tangkak is 50 km per hour. So meaning that from Segamat here to Tangkak, the speed is 50 km per hour. So let us recall, speed equals to distance over time. So now we are given the speed 50 km per hour equals to, distance is s, we don't know, okay. The time is 1 hour. So distance equals to 50 km, okay. Describe the motion of the car from Segamat to Muar. So meaning now we are going to describe the motion for the whole journey, okay. So we know in total the car moves for a distance of 80 km, okay. From here we know it's 80 km, and total time is 1.5 hours, and the average speed is 53 and 1/3 km per hour, okay. We have found it in part A. So we can see that there are three things involved every time when we describe the motion: distance, time, and the speed, okay. So we have reached the homework. Go back, you guys will complete this homework at home, okay, so that all the knowledge that we learned today belongs to you, okay. So if you are having a lot of difficulty, you are struggling in completing all this homework, I've prepared an online course for you guys, okay. It is a step-by-step guideline in helping you guys to complete all this homework at home, okay, including the comprehensive practice at the back of each chapter. So coming next, we'll learn to solve problems involving distance time graph, okay. So do not forget to subscribe to my YouTube channel so that you do not miss out any of my upcoming videos, okay. I'll see you in the next video. Bye bye.